In the 21st century, the world's energy demands have been on a relentless upward trajectory, driven by population growth, urbanization, industrialization, and technological advancements. As the global economies expand and the standards of living rise, the need for reliable and sustainable energy sources becomes increasingly imperative. As the global population is projected to exceed 9 billion by 2050, the demands for energy intensive services such as housing, transportation, healthcare, and education will continue to escalate, particularly in developing countries. This demographic shift places immense pressure on energy infrastructure and resources. As more people migrate from rural areas to cities, urban centers are becoming hubs of energy demand, requiring efficient and resilient energy systems to sustain their operations and support their populations. Fossil fuels, though meeting energy needs, contribute to environmental pollution, including greenhouse gas emissions and air pollutants, leading to climate change and respiratory diseases. While alternate sources of energy offer promise, they come with limitations. Many renewable energy technologies, such as solar and wind power, are intermittent, relying on weather conditions and posing challenges for maintaining a reliable energy supply. Some renewable energy technologies like hydroelectric dams and large scale biomass plants can also have significant environmental impacts such as habitat disruption and biodiversity loss. Scientists have been exploring nuclear fusion as a potential solution to address growing needs for sustainability. Nuclear fusion, the process that powers the sun, involves colliding one of the isotope of hydrogen, deuterium, and another isotope as tritium atoms to generate helium nuclei and neutron and large amount of energy and heat. Efforts to recreate this process on Earth have been underway since 1960s. Recently, in February 2024, with the projects like Eurofusion's joint European torus known as JET has produced promising results. This facility in Oxford has produced a record 69 megajoules of energy, maintaining the fusion conditions for 5 seconds. It involves the magnetic confinement of plasma at very, very high temperature in the shape of torus known as tokamak. The International Thermonuclear Experimental Reactor ITER in France is expected to be the world's largest tokamak, holds significant potential for achieving sustainable fusion energy. In southern France, 35 nations are collaborating to build the world's largest tokamak. While challenges remain, including uncertainties and technical hurdles, the successful development of fusion power could revolutionize global energy production, with hopes for a prototype fusion power plant by 2050. If successfully scaled up to commercial levels, it could produce endless amount of clean energy without carbon emissions.